Welcome to Architecture Homescape, Home Design and Architecture Idea. How to get started with 3D printed architecture. How 3D printing is changing the construction industry. 3D printing is revolutionizing construction by significantly reducing costs and increasing efficiency. Unlike traditional methods that require extensive labor and material waste, 3D printing automates the process, layering materials precisely where needed. This allows for faster builds, innovative designs, and sustainable construction practices. Companies like Icon and Cobod are already producing entire homes in days instead of months. With advancements in robotic arms and concrete extrusion, complex structures can be built with minimal human intervention. This technology is being used for affordable housing, disaster relief shelters, and even futuristic smart cities. Tips: if you're looking to invest in 3D printed architecture, start by researching companies already using the technology successfully. Understanding the core technologies behind 3D printed buildings. The core technology behind 3D printed buildings revolves around three main systems: gantry-based printers, robotic arm printers, and contour crafting. Gantry-based systems operate on a fixed frame, moving along the X, Y, and Z axes to deposit layers of material. Robotic arms provide flexibility, allowing precise printing of complex designs. Contour crafting, developed by Dr. Birot Kashnevis, enables rapid construction by extruding concrete in programmed patterns. This process reduces material waste and enhances structural integrity. Future advancements may integrate AI-driven adjustments, allowing real-time modifications during printing to improve precision and efficiency. Tips: understanding different printing technologies helps you choose the right method for your project's needs. Research printers compatible with your desired materials. Essential software for 3D printed architecture. Designing 3D printed buildings requires specialized software for modeling, slicing, and structural analysis. Programs like AutoCAD, Rhino, and Revit help architects create precise 3D models. These models are then processed using slicing software like Cura or Simplify 3D, which convert them into machine-readable instructions for the printer. structural integrity is analyzed using tools like ANSYS and SolidWorks, ensuring that designs can withstand real-world conditions. Some platforms, like Grasshopper for Rhino, allow parametric design, making it easier to create organic and complex architectural forms. Mastering these tools is crucial for optimizing efficiency and minimizing material waste. Tips: start with free or trial versions of software to practice 3D modeling before investing in full versions. Open source options like FreeCAD can also be a great starting point. The design process, from idea to 3D model. The design process for 3D printed architecture begins with concept development, where architects and engineers outline the building's purpose, size, and functionality. Using CAD software like AutoCAD or Rhino, a detailed 3D model is created, incorporating walls, openings, and structural reinforcements. Every component must be optimized for stability and printability. Once the model is complete, it is processed using slicing software like Cura or Simplify 3D. This step converts the 3D model into G-code, the language that guides the printer's movements. Engineers also run structural simulations to ensure the design can withstand real-world forces. Any necessary adjustments are made before finalizing the blueprint for printing. Tips: always test a small-scale prototype before committing to full-scale printing. This helps identify weak points and optimize material use. Choosing the right 3D printer for construction. Selecting the right 3D printer for construction depends on factors like scale, material compatibility, and printing speed. Gantry-style printers, such as those by Cobot and Icon, are excellent for large-scale projects, using robotic arms to extrude concrete efficiently. Robotic arm-based printers offer greater flexibility, allowing for intricate and curved designs. It's crucial to consider print bed size and automation features. Some printers can handle multiple materials, like cement mixtures, clay, and bioplastics, expanding creative possibilities. Speed and layer resolution also matter. Faster machines save time but may sacrifice detail. Researching printer specs and user reviews helps ensure the best investment. Tips: before purchasing, check if the printer is compatible with local building regulations and available construction materials. Materials used in 3D printed construction. The most common material in 3D printed construction is concrete-based mixtures, designed for fast curing and structural strength. These mixtures often include cement, sand, and special additives to improve bonding and durability. Alternative materials like geopolymers and clay-based composites are gaining popularity for eco-friendly and sustainable construction. Biodegradable and recycled materials are emerging in 3D printed architecture. Companies are experimenting with hempcrete, recycled plastic, and even soil-based mixtures to reduce environmental impact. Some projects integrate insulating foams or hybrid materials to enhance energy efficiency, making 3D printed homes more sustainable. Tips: always test material compatibility with your printer to ensure smooth extrusion and structural stability. Preparing the construction site for 3D printing. Before 3D printing a building, the construction site must be leveled and stabilized to prevent shifting during the printing process. This involves clearing debris, grading the land, and compacting the soil to create a solid foundation. Some projects may require reinforced concrete slabs or additional groundwork to support the structure's weight. Power and material delivery systems must also be set up. Large-scale gantry-based printers require precise rail installations, while robotic arm printers need flexible movement space. Ensuring proper drainage and weather protection helps prevent disruptions during the printing process, leading to a smoother build. Tips: use real-time site monitoring tools to detect uneven surfaces or shifting ground before printing begins. Step-by-step guide to the printing process. The 3D printing process starts with loading the 3D model and slicing it into layers using specialized software. The printer then begins extruding material layer by layer, following the pre-programmed design. Each layer is carefully deposited and bonded to the previous one, ensuring structural stability and accuracy throughout the build. Once the walls and structural elements are completed, reinforcements like steel rods or insulation panels may be added. Openings for doors and windows are incorporated during printing, minimizing the need for post-processing. The final step involves curing the material, allowing it to set properly before additional construction, such as roofing or electrical installations. Tips: always conduct a test print on a small scale before beginning full construction to check printer calibration. Challenges and solutions in 3D printed construction. One major challenge in 3D printed construction is ensuring structural integrity, as layering methods can create weak points. Engineers solve this by reinforcing designs with steel rods or hybrid materials. Another issue is print precision, which depends on calibrating the printer and using high-quality slicing software to avoid errors. Weather conditions like extreme heat, humidity, or rain can impact the curing process of 3D printed structures. To prevent issues, projects use protective coverings or adjust material mixtures for better adaptability. Another hurdle is regulatory approval, requiring collaboration with local authorities to meet building codes and safety standards. Tips: always conduct material and stress testing before large-scale printing to ensure long-term durability. Regulations and permits for 3D printed buildings. Navigating building regulations is crucial before starting a 3D printed construction project. Many regions lack specific codes for 3D printing, so builders must work within existing concrete or modular housing laws. Consulting local authorities early helps determine zoning rules, structural requirements, and safety compliance before construction begins. Permits typically require proof of material strength, fire resistance, and durability testing. Some countries, like the US and the Netherlands, are actively developing new standards for 3D printed structures. Working with licensed engineers and construction firms can speed up approval and ensure compliance with evolving regulations. Tips: stay updated with local and international 3D printing codes, as new policies are rapidly emerging in the construction industry. post-processing, and finishing touches. Once a 3D printed structure is complete, post-processing enhances durability and aesthetics. The first step is surface smoothing, using grinding, sanding, or plaster coatings to refine rough layers. Sealants and waterproofing treatments protect the material from moisture, improving longevity and structural strength. Additional features like paint, insulation, and wiring are installed to meet living or commercial standards. Some projects integrate cladding materials like wood or metal to enhance aesthetics. Final inspections ensure structural integrity and compliance with building regulations before the space is officially usable. Tips: use eco-friendly coatings and insulating materials to improve energy efficiency and sustainability. Business opportunities in 3D printed construction. The 3D printed construction industry offers multiple business opportunities, from housing solutions to commercial structures. Entrepreneurs can focus on affordable housing projects, providing cost-effective homes in underserved areas. Other opportunities include custom home design, eco-friendly buildings, and modular 3D printed offices. Businesses can also offer 3D printing services to real estate developers, reducing construction time and labor costs. Sustainable materials and smart home integration present new markets for eco-conscious clients. Government-backed projects, such as disaster relief housing and low-income housing programs, create additional revenue streams. Tips: stay ahead by partnering with architects and engineers who specialize in digital construction methods. Future trends in 3D printed architecture. The future of 3D printed architecture is evolving with new materials, AI integration, and automation. Researchers are developing self-healing concrete and biodegradable composites to create more sustainable buildings. AI-driven generative design will optimize structural efficiency, reducing material waste while enhancing design flexibility. Multi-material 3D printing is expected to revolutionize construction by combining structural, insulation, and aesthetic layers in a single process. Mobile robotic printers will allow on-site construction in remote areas, disaster zones, and even space colonies. Governments and corporations are investing in fully automated smart cities using 3D printed infrastructure. Tips: stay ahead of the industry by following emerging tech trends and investing in adaptable 3D printing systems. Getting started: your first 3D printed building. Starting your first 3D printed building requires careful planning, equipment selection, and material sourcing. Begin by choosing a design, using CAD software to create a printable 3D model. Next, select a suitable 3D printer based on project size, whether it's a gantry system or robotic arm printer. Prepare the construction site by ensuring level ground and proper material mixing. Load the print file into the printer, conduct a test print, and monitor the layer-by-layer construction. Once printed, focus on post-processing steps, including surface finishing, insulation, and final inspections before occupancy. Tips: start small. Experiment with smaller scale prototypes before committing to a full-size building project. Conclusion: the future is here. Start building. 3D printed architecture is transforming the construction industry, making building faster, cheaper, and more sustainable. With the right tools, knowledge, and preparation, anyone can explore this revolutionary technology. Whether you're an entrepreneur, architect, or DIY enthusiast, now is the time to start experimenting with 3D printed construction. As materials improve and regulations adapt, 3D printing will become a mainstream construction method. The potential for affordable housing, disaster relief, and futuristic cityscapes is limitless. Take your first step today. Design, print, and build the future. Tips: stay updated with new advancements and join online communities to learn from industry pioneers. Thanks you for watching. Don't forget to subscribe, share, and comments. See you on next video.